Alright guys, here we are. Maybe I should have done this in the very beginning, but let's take a look again at limits. The informal, well actually all of this will be informal because we don't have enough math knowledge to prove this formally. That's when you're a math major in college. Because you're all going to do that, right? I think. No? Well, alright. The way I think about a limit is what a function approaches. What is the function going to as the x value goes to something else? So the limit of this is very, very informal. What the function goes to as the x value goes to something. That's super vague. Another way of saying this is a little bit more precise. The limit of a function is what the y value of the function approaches as the x value approaches a specific value. That's so many words. What is the y value getting closer and closer to as the x value is getting closer and closer to something else? The notation, the way we write it, so that you can copy that down, pause it or something. The way we write this, of course, is like I show you right now. This means the limit as x approaches a from the right and the left. It's a two-sided limit. The limit as x approaches a of f of x is L. That's how you would say that. And then I wrote it down backwards. The limit of f of x as x approaches a is L. That's how you write that. That's so far so good. Okay. Alright, we're moving right along. What am I going to talk about next? Probably something involving limits, because that's what I'm doing. How about for a limit to exist, the left-hand limit and the right-hand limit have to agree. Let's say that. For a limit to exist, the limit from the left must agree with the limit from the right. They also have to be a number. It has to be a number, okay? It can't be like an infinity or something like that. What about the ways to evaluate a limit? Well, this is a lot of words so far. What ways can you evaluate a limit? It's just a question. I don't know. Maybe you know the answer. How about you tell me? You can't because it's a video. I know what's going on. How can you evaluate a limit? That's the same thing as saying, how can you see what the y value is approaching as the x is approaching something? Well, just a couple ways. You already know because we've been doing it. But like, you could try some like make a table of values and see, like plug in stuff, you know. So you can do it numerically. That's what it's called. You plug in x values as you're approaching some number. In this case, it looks like we're approaching. I just made this up. We're approaching 3. Yeah, look, this guy is approaching 3 from both sides. This is from the underside, and this is from the overside. Oversight? No. So you can plug in things that get closer and closer to whatever you want the x to get closer to, and then see what comes out for the y values. Okay, that's numerically. Bam! You could also do it graphically. You could look at the graph. So what does that mean? That means you can approach A from either side. That means, well, when you're approaching, if you're doing it from a graph, if you're approaching some A value, okay, meaning your x is approaching that A value, you have to be approaching from on top of your function, okay? So from the left side would be like that. From the right side would be like that. You cannot approach A from here because there is no function here. You cannot approach A from here because there is no function there. You must be on top of your function because you're seeing what the y value approaches. Okay, so like this is approaching there. Let's take a look. Like if this is like I approach A from the right side. And my y value, you can see, is getting higher and higher and higher and higher. Right? So it's approaching whatever this is. If I'm going from the left side, my y value it gets higher and then it gets a little bit lower. It's approaching this. So the limit as x approaches a for this particular picture will be f of a, whatever that is. I don't even know. So that's graphically. You approach it from your function, both sides. You know, if they don't agree from either side, it doesn't exist. As simple as that. I need more room. Oh, I got more room. So to evaluate some algebraically, we're gonna use, you know, like some tricks. That's when we have the stuff that, you know, approaching from the left side and the right side, but as x approaches a of f of x, and then there's going to be an equation, not an equation. There's no equal sign. There's going to be a function there, and we're going to have to do some tricks. This is when we're going to have to do the tricks. The tricks. What are the tricks? We're not gonna, not like. Well, we'll get to that. First, maybe I'll finish up this video with talking about the notation with the left and the right, huh? With the left and the right, say? Okay. We're getting dizzy. So that's how you say it. The limit of f of x as x approaches a from the left. That means you're plugging in things that are actually a little bit smaller than a. So here we're approaching a from the smaller side. So what's coming up next? Approaching a with values that are slightly smaller than a. You know what's gonna be next? You know, little guy. What you think? You know what's gonna be next? Yeah, that's right. From the right side. Huh, right? I get it. It's a pun. All right. There you go. The limit of f of x as x approaches a from the right. Those are the notations. For a limit, did I already write that? For a limit to exist, needs to agree from both sides. For a limit to exist, the left and right must agree. Yeah, I wrote that down already. Okay, I think we're going to be done with this video right now. I think it's getting pretty close to 7 minutes, and so, you know, there's going to be another video, maybe like with, you know, like a, I'm going to leave. Bye.